Good afternoon. I think we'll wait for an extra 2 minutes before we start, so that more people can join the meeting.
Hi everyone, good afternoon.
Good afternoon, Simon.
Good afternoon, sir.
Nice to see you all today. I guess we can go ahead and slowly get started. I guess more people will continue to join, but we can sort of begin the discussion slowly, and I think we can still have people joining. Is that okay with you, Henry? Yeah, I guess so. Okay, so my name is Simon. I work in Aarhus University in the Department of Management and the Niels Bohr Institute in the Department of Physics. I'm head of operations in the DigiQ Quantum Technology Master Program, which is the largest quantum education project in Europe. And I'm head of operations in the European Quantum Readiness Center, which is our center that we have based in Aarhus, where we're trying to help understand how we can best prepare Europe, but also the whole world, for what's coming in the quantum revolution. Um, so before I go ahead and introduce my work, I want to make a comment. We have a good amount of time today. I don't know if we'll take 2 hours. We may take 1 hour or 1 hour and a half. We'll see how we go with the discussion. But today very much is intended to be a discussion. So there will be several interactive activities where we're going to all participate together in a collaborative Google Doc. So I actually want us to try to engage in that if possible. And so there's going to be that, but there's also going to be a chance for you to ask questions and start a discussion about anything that I say which resonates or you find interesting. So you don't have to wait till the end of the talk to ask questions or to mention a comment. Just use the raise hand feature in Zoom or type it into the chat, and we can start a discussion at any time. So there's the whole point is that we all learn together, and so that's sort of the idea behind this. Um, to that end, it would be great if you could just write your name and a sentence about your work in the chat. You can see I've written that there in the on the screen. So just type in your name and the group chat in Zoom and what it is that you do. So I have an idea of sort of who I'm talking to when it comes to what kind of information you want to know and how I can best sort of get it across. So you're going to hear a little bit today about the National Quantum Strategies analysis that we've done. I understand that this is something that you're working on in Ghana. So that's very interesting and would love to be able to help you and hope that this can help in some way. So we're going to talk about the national strategies. We're going to talk about a few other things as well, all related to the quantum ecosystem and how it's been developing over the last few years. And so at any point, please feel free to just drop in and make a comment or ask a question. But we'll go ahead and get started. And please do type in your name and a sentence into the chat so we can all have an idea about what it is you want to get out of today's session. Great. Okay, so you may have seen this graphic before or something like it. The numbers are going up is the main point I want to make here. The number of investments in quantum across the world are going up a lot. And this is even from 23, so it's gone up even more now. And it is not just in the US and in Europe and China, or it is in lots of countries. It's in the Philippines, it's in Thailand, it's in Qatar, smaller countries, South Africa. They recently published their quantum strategy a couple of years ago, and in many places in Africa, as I was very fortunate to hear about at the Quantum Education Summit, where Henry Martin invited me to this talk today when I heard about the work being done in Africa. So these numbers are going up a lot, and they're going up, they're spreading to more places in the world that they weren't before, and that's something that we can be excited about. But and there are other indicators that we can also be excited about, like for example, the growth in the number of companies. This is the figure on the left here. There's been a big growth in the number of companies in quantum in the last few years, the last decade or so. A huge growth in the number of educational opportunities, so ways for students to be taught about quantum. The workforce is getting much bigger, much quicker than it was in the last few years. And I've done some research about that, and you can see it in the figure in the center there. And forecasts of job growth into the future are also very optimistic that we're going to need many, many, many quantum trained people to work in this industry. So there's potentially a bright future ahead. But we also have to be cautious because there are some indicators that maybe are not necessarily so positive. So, for example, the number of quantum startups. So we have lots of bigger companies coming, but the number of startups being created per year has actually gone down recently in the last couple of years. Maybe COVID is a factor, but we need to consider that. The stock market evolution of the big companies, the quantum computing powerhouses, are not necessarily trending upwards. That's maybe how so that's something we should be aware of, that they're not universally known to be successful yet. And there's a large disparity between research and industry projections. So when you ask companies when they think quantum computing is going to give them a competitive advantage, they say within 2 years or within 5 years. But when you ask the researchers the same thing, they say a longer time frame. And so the gap between what people expect to be able to use quantum for and what quantum can actually do at the moment is that there is a gap there and there is a mismatch. Great. Finally, there's been a big increase in the number of companies claiming to look at use cases and use case activity. But when you dig into what they're saying, many of them are saying we're trying new things, but they're not necessarily real use cases and really giving us a quantum advantage over something we couldn't already do. Maybe they're doing it in a different way. They're doing it with a quantum method that is a new way of doing it, but it may not be necessarily any better than doing it in the classical way. That doesn't mean to say that they won't be successful in the future, but it does mean to say that we simply have to be cautious, and we're going to talk about this quite a bit today, in our message and what we say, because the message is very important. And we've seen it in the AI world, that the way that the message can easily run away from what the state of the actual technology is. And so we don't want to do that with quantum, and we have to be a bit careful. So that's what I mainly want to say about this. We have to manage expectations. So we have to be careful about hype and overhyping the technology. And we have to think about how we're going to actually develop it in terms of the message. If you look at this figure at the top, this is from Oliver Zerati's work, looking at the quantum hype. He compared quantum to different technology areas. And so there's the web at the top, there's the telephone, radio, and television at the top. And then there's some things which haven't worked so well, like ultra wideband networks, flying cars, and some other technologies that we don't hear about very much these days because they didn't take off. And so how do you chart the growth of a technology, whether it grows in a positive way, successfully or smoothly, or whether it has a sort of more rocky journey? And well, a big part of it is the expectations and managing expectations. And because with expectations comes investment, and with investment comes development. And so this figure is actually more relevant than it's not just hypothetical. This is really how industries develop, or it's a map of how industries develop. So with quantum, we have to be cautious about what we say. And we also have to give honest benchmarks and realistic timelines and rigorous outcomes of what we do. And then we can end up with a positive outcome. That's this trough that's sort of shown in the figure there, that once you get to realistic outcomes, you can get a positive slope. But we have to have realistic outcomes. Okay. We're going to come back to that figure a little bit later with one of the activities. So I hope we can do that. Great. So here's the agenda for today. I'll first introduce you to the EQRC, the Quantum Readiness Center that I'm a part of. And we can talk through a little bit about what the EQRC does, our background, which is in quantum workforce development or education. And we'll talk a little bit about what we've done in Europe, which maybe can be useful for looking at what's done in Africa. We're going to go through the topic modeling of the national quantum strategies, the research we've conducted recently in the EQRC. And we looked at the different national strategies of the countries worldwide. We're going to then talk about the strategic narratives in those strategies. So this is something we are working on at the moment, but there's a lot to be learned from the way that they're talked about in the documents. And so it's about what the US says and what the EU says and what Japan says and how they talk about it. So we're going to try a little activity there. Then we're going to look at the job marketplace, and in terms of the sort of the global distribution of the jobs that are available in quantum and how that maybe is related to what the countries are doing. And then we're going to have a roundup activity. Great. Okay, so as I said, there'll be some interactive elements. So please make sure to participate in those in order so that we can actually have the most out of today's session. So I hope you can put your name and a sentence about what you do in the chat so that we can start with that. Great. Any questions so far about what we're going to do today? And if not, then I'll just go right ahead.
No question.
Oh, hi, Henry. Go ahead.
Yeah. Oh, okay. So at the moment I have no questions, so you can go ahead.
Oh, okay. Fine. Great. So we are the European Quantum Readiness Center, as I said, and we were established under the Quantum Flagship, which is the funding body for quantum technologies in Europe. And the idea with the EQRC is to help to understand the quantum ecosystem, because originally we were created to work in the workforce development and the education field. But we said, how can we understand what to teach if we don't know what we're teaching toward? What will the quantum ecosystem be like in 5 years or 10 years? And what do we want it to be like? How can we steer it in the right direction? And so that's the goal with the EQRC. Help to steer the quantum ecosystem in the right direction. Of course, in Europe, but we work with organizations worldwide. Yeah, we want to support the quantum readiness of every institution and company. The idea is to develop resources, which we will see a little bit of today, provide analyses, and you're going to see some of that today as well, and then help to promote adoption of best practices, which are things that we can learn about from these analyses that we do. Great. Okay, so for an example from the resources we have, and feel free to just go to the website and have a browse yourself. Type it in the chat. There, great. Yeah, so we created this quantum playlist, which was made for the European policymakers because they asked us. We don't have any quick and easy and accessible material for quantum that we could use to help us to understand the field. Can you create something for us? And so we did that with the EQRC, and we created this playlist. And we've sort of compiled all the material from the education community in Europe from the last few years as well. Now, I'll give you a brief aside about the quantum education activities in Europe, because that's been my work for the last 4 years, and I think it's really relevant to the discussion today. So we're going to take a brief aside on that, and it's all available now on the EQRC website if you want to see what we've done. But we'll make a brief mention to that. So it's where I started, and it's where we started as an organization. We've now moved more into this sort of the European strategy area, but we sort of started off as a workforce development center. And the sort of workforce development timeline in Europe has been thus. The Quantum Manifesto, which you may have heard of, was signed by around 100 academics in Europe and industry members. There wasn't so much quantum industry at that time in 2016, but it's primarily academics. And it was a call to the European funding body, the Commission, to launch a quantum funding program. And so they just sat together in Grenoble in France, and they just wrote down a big list of things that they wanted and they thought that Europe needed in order to catch up with the US, who has already started their program. And so the Quantum Flagship was launched in 2020, and it's a 10-year, €1 billion investment. Initially 1 billion euros, it's now gone up to 1.5 billion. And as part of the flagship, the European program, they decided there was an important and a need for an educational community. So at that time, there was basically no formal education in quantum available. There were no programs in it. I mean, if you studied physics at university, you would study some quantum courses. Most of us in this call maybe did that, for example. But there was no formal educational pathway for students to go and say, I want to go and work in quantum computing, and this is what I need to study. At that time, things have changed a lot in the last few years, and that's part of what's been happening here. In the QCATS project, that was the flagship's coordination action, and we were asked to manage the education community. And in the DigiQ and QT&Do, they've been developing quantum content and developing programs, and you'll see a bit about them in a second. But this is sort of the timeline how it happened, and in particular, this QT Edu project in the center has sort of been responsible for developing the educational community in Europe. So we're going to talk about that briefly here because I want to make sure it gets a mention, as it's a very unique kind of strategy that the European Union used, because this QT Edu project, maybe we have a slide on it, we'll have in a moment, we'll come back to it. This QT Edu project was a 2-year program, or 3-year program, sorry, that was funding just a handful of organizations to coordinate a large community. So 4 or 5 organizations came together to work on this project, and we were one of them in Aarhus. And the idea was to build a community, and we did that with working groups and pilot projects, and you're going to see it on a slide in a minute. But the QT Edu team was actually only a small team, and that meant that we got a lot out of this community for very limited resources. All the project was just a small team with a few people. And yet we were able to coordinate a very large community, which has grown into something really quite big. And we had a conference, the Quantum Education Summit in Europe just recently. We have journals which are specialists on this topic, which are based in Europe. And so the field has really grown a lot, and this project has a big part to play in it. Another aspect that was developed also in the European strategy was this competence framework, and the EU loves competence frameworks. They do it in other areas as well. They don't do it just in quantum. They've done the competence framework in digitalization and entrepreneurship, many different areas. And this is supposed to be a common language for curricula and skills. And so if you look at it closely, you see it's a kind of a map of the topics in quantum. And so you've got the concepts, the basic concepts, the sort of physical foundations, like the type of platforms, enabling technologies. And then you've got the applications like computing and communication, sensing, and then you've got valorization, which is kind of bringing the quantum into society. So it's business aspects and things like that. So the idea was to make this map of topics that could be used to create a common language. Now, we'll come to see that in a moment, but if you see here how it was made, the framework was made with a 3-stage Delphi study where they had questionnaires sent to different stakeholders, and then they were experts interviews, and it took a very long time to make. So it started off, the first pilot was in 2020, and the latest version of the framework was last year. So it's been a 5-year development process, but this has been a really exciting thing to come out of Europe. And then the latest aspect of these 9 qualification profiles, which are essentially a way to talk about a type of work that someone might do, a type of employment that someone might have, by referring to these areas of the framework. So, for example, if you were a quantum business analyst, then what would be your main areas of work? Well, they would be basically, you would need to know most of the topics in quantum to a very limited degree. You wouldn't need to be a technical expert, but you need to be able to engage in a conversation about communication or sensing or computation insofar as they would be relevant for the business that you're doing. So if you were a business analyst, then you would need to have a certain level of understanding. And if you're an engineer, you might need to know very much detail about topic number 5, the quantum computing topic, and number 4, the quantum hardware topic. And so your profile would look different. And this is a way to visualize these profiles, and it's a way to help to match students towards particular jobs. So they can say that I want to do the business analyst, I need to get the triangle, the profile looks like this one down here on the bottom. And so that's the main idea there. Great. Standardization allows the different aspects of the ecosystem to talk together smoothly. So the industry can talk smoothly with the universities and the training facilities, and the candidates can know exactly what they need to study in order to know exactly what kind of job they want to do. Whether or not they will actually know what jobs they want to do is another question. But whether, if they, insofar as they know that they want to work in quantum computing, they can know what they have to study to get there, and that's a really valuable thing. And it's valuable for the developing curricula because they can help to provide those pathways from the off for students. Great. So like I mentioned, this project brought together volunteers essentially volunteers in the academic and the industry community, to bring them together into working groups for concrete actions, basically on a shoestring budget. So you can see this board that's on the middle of the screen there. This Miro board is from one of the working group meetings in the quantum education community. So we were really excited that so many people were interested in working together, in collaborating on these topics of quantum education. And so we were able to bring them together to contribute to the roadmap for quantum, to develop synergies and collaborations, and then to work together on these concrete pilot projects, which I'll talk about in a moment. The important point here is that at the time we were saying, that we need changes on two timescales, that there needs to be a quantum workforce already and quickly to fill the roles in the jobs which are available. And at that time, in particular at that time, there were not there were not so many applicants for any given job. In fact, the jobs were struggling to fill the roles. It's it's not so much the case anymore, but it was the case back then in 2020. Now we also need a longer term change. We need a society that's more quantum aware. Quantum is in the news all the time now, at least it is in Europe. I don't know how it is in Africa, but I guess it probably is as well. And so we need people to know a little bit of what it is and not be worried about it, not be scared about it, but maybe be excited. And like I mentioned at the beginning, managing the hype appropriately so that we can help to develop a flourishing industry that is not overhyped and sort of dies an early death, like some of them have in the past. I don't think quantum will, but we need to manage our expectations. So we brought together this community on a shoestring budget, and they formed together these pilot projects, these 11 pilots. And this is a model for community building that I think is extremely effective, because we got them to work on things that they were passionate about and they were interested in. And that these are sort of proof of concept ideas in the education world. So can we develop school material using what we have? For example, can we teach quantum in the schools? Is there any way we can teach quantum in the schools, the high schools, for example? What can we do in a university level? Can we help the university share courses? For example, these kind of things was sort of on the agenda of the staff involved in the community, and we wanted to be able to help them. And so we set up these working groups and these 11 pilot projects. Great. Yeah, QTAD's had a big effect on the community and the education landscape, I would say. As the number of publications has shot up, top publications on the topic of quantum education. This is, like I said, there was a conference, specialist conference on the topic this year. There's a journal issue on the topic. This topic is sort of on the map that it wasn't really before. And as we're going to see a little bit later, it's made its way very significantly into many of the strategies of the nations worldwide. Europe are not the only people who recognize the importance of this, and I would be interested to hear how it's being tackled in Africa. But I would say it is likely also being recognized. But you guys can tell me better, I think. So two examples of those pilot projects that worked. One of them was this outreach pilot, which was about storytelling for quantum science and technologies. And they hosted this Italian Quantum Weeks, an 8-week long outreach sort of festival in 17 cities in Italy. Amazing, amazing initiative. They were in, all these beautiful old Italian cities, in sort of Roman ruins. And they were celebrating the quantum using museum exhibits, board games, meetups, music and art and storytelling. And so they compiled this sort of list of resources that could be used for doing outreach, and outreach is very important. And it's the first step towards workforce development on a longer time scale because it brings people together who are interested in the topic. There was also the Open Master Pilot, and this was where we brought together universities who were teaching quantum at a specialist level, the master level, and they were maybe had a very specific expert in their university who was a very good expert teacher on a particular topic, say quantum liquids, for example. Or, and maybe you couldn't get this particular specialist topic in another university. So we set up an online course sharing platform where students could access courses taught by universities in different countries in Europe. So you could be in Denmark. You as a student could be studying in Copenhagen, and you could study this course from Prague, quantum programming course from Prague, because I knew we have a great expert there who could be able to teach you about that topic. And so this was allowed us to really help. Copenhagen's not a good example because Copenhagen is a well-resourced quantum hub in Denmark, and so they've got their own quantum program. But smaller universities without access to quantum experts, enough experts to make a whole program, could use courses from universities in Europe and take them and teach them to their students, and then the students could get credits for studying from those. And so we did some research where I interviewed the members of staff from different universities about how they did this course sharing and how did it work, and were you able to get credits for your students? And so that's sort of what you can see there in the timeline at the bottom. So this was, and as a reminder, this one and the one before, they were pilot projects that were completely unfunded and voluntary, and yet they proved proof of concept that they can make things work. And so that was very valuable. You'll see in a moment that we use that to sort of leverage to future funding. The quantum education community, I just want to highlight this QT project. I think it was very impactful, and if you want to read more about it, I think you can look at this article, Quantum Building Europe's Quantum Technology Education Community. You can find it online, it's open access. If you just Google the name, you'll be able to find it, where we talk about how this project helped to develop the community, and how these pilots came together to work towards bigger actions. So you can read about that, and it's from the EQRC that we worked on this article. Okay, so now, as I mentioned at the beginning, I'm the head of operations for DigiQ, and this is Europe's Quantum Master Program, where we're developing 60 ECTS or 120 ECTS programs that students study. And so 250 odd students a year go through this, and they get trained and they get a master in quantum technology. So that's sort of the state of where we're up to now. And so I'll just highlight to you some more that there's been a lot of research into the quantum workforce, quantum workforce development done in the EQRC. And so you can find any of this if you just Google quantum EQRC or Google my name. Then if you want to know more about what we do, you can find it there. Great. So that was a lots about the quantum workforce in Europe and what the strategy has been. And the strategy has very much been community first. That we start with building a large education community, and then getting them to work on these pilot lines and pilot actions, and then being funding the large initiatives like this DigiQ, this master program. But okay, so I've been working in this for a while, and I've been involved in this field, and something that we think in the EQRC is that in order to understand the workforce, we need to understand what we're training for, what we're training toward, and what do we want the ecosystem to look like in the future. So, and what does it look like now, for one thing? For one thing, at the moment, it looks like it's growing a lot in this region of ecosystem builders. So, when we were early in the quantum sort of world, yes, there were some educational institutions that were just getting started, but you were mainly teaching quantum in through other programs. The industry was obviously much smaller, and there were far fewer industry consortia, and there are now many industry consortia. And in particular, these ecosystem builders and regional hubs are areas, cities or few cities or regions of different nations that have come together to work on building their local quantum industry. And there's one in Catalonia that was hosting the summit I was at, in Saxony in Germany, I'm in Finland, and there's loads of them, and you can see it there in the figure. And this is not an exhaustive list, and I'm sure we're missing some from Africa, for example, and I'm sure that there are as well. This is a non-exhaustive list of examples, and of what the kind of national programs look like, and how the ecosystem has changed. It's growing in the sense of national developments. It's definitely growing in this area. Oops. Great. Okay. So that was an introduction to what we do and where we came from. We've been responsible for lots of the workforce development in Europe, and now we're sort of trying to understand from an ecosystem perspective what we're trying to work towards and what we're training for. And so we're going to now talk a little bit about this topic modeling of national quantum strategies. There'll be an interactive part to this as well, so I really hope that you can participate in that. And then we're going to see a little bit more as we go on. Great. Okay, so topic modeling, that's what we've used in order to investigate the national strategy documents. And you're going to see the full data set in a moment, but I just want to introduce you to this method in case you haven't heard of it. It's an AI method, and it's a classical AI method, not a sort of modern deep learning, ChatGPT type of method, large language model method. It's a classical method to identify topics from large volumes of text. And so it's actually not that complicated to think about. You sort of take loads of text and they live in this vector space with meanings of words. And then you sort of cluster the words of certain meanings together. And then they cluster into kind of a 8 or 9 or 10 or however many topics dimensional space. And then you cover 99.9% of all the text with however many dimensions. And then you cluster each of these dimensions as a topic, and then you just categorize the text into the topics which are primarily representing it. And so it's actually conceptually quite simple. But we've used that, but computationally quite difficult to get accurate topics and to get topics that sort of make sense, and also to make sure that the text is in a readable form without sort of errors and without things that don't belong there. We'll talk a little bit about the text cleaning soon. So this work represents the first use of a natural language processing method to look at the text in quantum strategic documents. And we've done that because we want to understand what are the main topics in these documents. What do the governments talk about? What are their strategies? What do they want us to develop in quantum, and what do they say about it? So here's our data set, 62 quantum strategic documents, authored by the government or commissioned and endorsed by the government. So the first one is in 1999, and it's from the US, and it's the first use of the term quantum technology. And sort of since then, there's been many of them from the US and from Europe, and the ones from Europe in particular. Many of these are sort of consultations in the quantum community in the early days of 2005 to 2010. But since then, we've had many more nations who've released their national strategies. South Africa also in 2021. And as you can see, we go up to 2024 when we stop collecting data to work on this first publication about this. There have been more, obviously, in 24 and 25. There have been many more national strategies. And if we were to repeat this, we could include the new ones. But the data you're going to see so far is what we have from 23 and 24. Great. Here's an example of what the Danish one looks like, the National Strategy for Quantum Technology. And the European one is the Strategic Research and Industry Agenda, which you can see down there at the bottom. Great. Okay, we have 20 countries, already nations, because the EU is also included there. And I guess that one's more of a union. 12,728 paragraphs in total, and we sort of clustered them to 13 topics. The EU represents a big chunk of the data set because there's the individual countries, but there's also the EU as a union, and then the US and the UK. We also have one strategy from smaller countries like Thailand, like South Africa, Slovakia, Ireland, etc. Israel. Yeah. So some of them are national strategies from the governments directly, which is written by the government. Other ones are reports written by the government that are not necessarily called as a strategy, but they're government reports about the state of quantum. And some of them are third-party reports which were commissioned by the government. So the key criterion was always that they were either written by the government or commissioned by the government. So some of them were third parties, but the government authorized them and commissioned them. Finally, there's only one legal framework about quantum in the world so far, and it's the National Quantum Initiative Act in the US, and we have that one. It's a law. Here we go. It makes quantum a national priority. It was established in 2018. And the US uses this kind of legislation to signal long-term credibility. So the investors, and the US has a lot of private investors, venture capital, they feel safe investing in quantum companies in the US because they know that the US is prioritizing it because it's in the law. So that's the sort of advantage of making a quantum act, a quantum law. It has pros and cons. On the one hand, you're tying yourself to this field, and you have to really believe in it. But all of the nations, as we saw in the first figure, in the amount of money they're spending on it, they all do believe in it, and rightly so. And so it's a good idea to make a law on it. And it makes the venture capital and the investors more comfortable in investing in it because they know you're not going to drop it, because they know you're prioritizing it. So that's something to consider, that how how these kind of laws can be helpful in developing quantum strategy. The EU is planning to do this as well. So next year, there will be a Quantum Act going to the European Parliament. This has been part of the EU's quantum strategy, and the most recent one. And so this is also why I said that quantum is going to be everywhere very soon. This year has been the International Year of Quantum, and it's already been in many in the media a lot. But next year, it's going to be in the Parliament for a second time now. But when it was in the US Congress in 2018, at that time, quantum was less of a big presence in the world, so I didn't get as much media attention. But I think that next year, or this year now, actually, when the Quantum Act goes to the EU Parliament, it's going to get a lot of media attention. And so we want to make sure that we have a good message about what quantum can do for us and not overselling it, but not underselling it either. Great. Yeah, okay, great. So key priorities are obviously research and innovation, trying to foster synergies between the different European countries, strengthening technology transfer and making sure that different countries can access relevant skills, and so talent, of course, but also resources. And so that's important. It's about industrial capacity as well. So making sure that we have relevant manufacturing capabilities for things like quantum chips across Europe that the different countries can all access. And it's about supply chain resilience, so making sure that we can take account the right kind of governance so that no country gets left behind in terms of, for example, getting access to hardware that another country can easily get. So it's about making sure that's unified across Europe, and that's what this Quantum Act will help to do. Great. So it's something to consider about whether or not it can be useful for Africa as well. Okay, so looking back to the documents now, how did we take the data? Well, we pulled out, as I said, 12,728 paragraphs. And we first used LLMs to convert them into paragraphs. So we just get a big block of text and we convert this into the paragraphs. Then we clean out and filter the paragraphs to make sure we only have relevant information for the natural language processing to do. So, for example, we get rid of fig images and we get rid of bits of text formatting like bullet points and things that can't be read by the NLP. And then finally, we do topic modeling to identify the themes and cluster them in the documents. And here's what we end up with. And so we have 13 topics in these documents, and you can see them all there on the screen. I'll give you a minute just to read it and see if there's anything you notice. So how about you just have a quick look at it and then either write in the chat or or just open your mic if you want to say any comments about it. Just have a quick read of it.
Okay, Simon, I have a question.
Hi, of course.
Yeah, so what do you think is common or the common things across all of these strategies?
Yeah, we're going to see shortly the sort of the most recurring things, but it's sort of changed over time. And so some of the most important things are, apart from the basic science, is the transversal topics. So it's the governance, it's the making sure that we have a coherent ecosystem in the nation. It's the making sure that we have equitable access to things like hardware and equitable access to parts. And it's also things like the workforce. So do we have the skills and do we have a way to get talent for what we need to do? We're going to see it in great detail very shortly. But those are some of the more common things. To be honest, in the 62 documents, there's no single thing which is common to all of them. They actually do have quite some differences in each one, but some of the most common things for sure are this equitable access, the importance of governance, and sort of the workforce.
Okay, thank you.
Right. So, okay. In fact, what you can keep reading, but in the meantime, I'll tell you that I've broadly grouped the topics into three categories. The white ones there are sort of these more transversal ideas of governance, national, international research collaboration, workforce development, um, innovation and industry and investment. These are sort of the things which are talked about the most in the documents. And then we have in the blue, we have the sort of enabling technologies, the underlying science. So we have basic science, which is the top quantum physics and information theory there. But we also have things like photonic systems, which are the ones that get named and mentioned the most as far as platforms go. We have a more topic about the atomic systems, atomic clocks, lattice ion traps, etc. This is the quantum platforms one. And we have one which is specifically about spin. And so again, more kind of basic science. So those are the blue ones. And then the orange ones, we have more of the application domains. So computing, sensing, communication, and algorithms and simulation, they all come up as individual topics. So that at least tells us something that we're probably on the right track in terms of looking at the documents, because this is in all of them and this is what we'd expect because this is what we think of. We think of quantum technologies. Great. So, okay, any more questions about the specific? Because we're going to get to go in a lot of detail about them. So I think I'll just go to the next one. Great. And we're currently working on the sort of research paper about this. So we don't have a final article to download yet, but this is all preliminary. But the data is not going to change now. So the data is final. The broadest trend that we have in the time since the beginning of the data set, which was 1999, to the modern day, 2026, or 24 actually, when this data set was, are an increase in these more transversal topics, the innovation and the investment. That's gone up a lot as a sort of topic in the documents. That's become more prevalent. The education and workforce development, that's also become a lot more prevalent. And the information theory and the physics, the basic science aspect, that's kind of gone down in prevalence in the documents. They're not talking about that as much as they used to. Doesn't mean to say it's not important, and doesn't mean to say that they're not talking about it at all. But just because there are now other topics being mentioned as a fraction of the documents, the prevalence is going down in the physics and information theory. The other ones, yeah, there's been some up and some down, but broadly not massive changes. These are the ones where you really notice a big change. Yeah, the takeaway, the overall picture then is that governance, education, commercialization, and other transversal topics are increasing in prevalence. The quantum pillars, yeah, they're also increasing in prevalence relatively to the basic science and the foundational topics. They're decreasing a bit in prevalence. In fact, this figure, maybe with the three colors, the blue and the green and the yellow, that shows it quite clearly. You can see the blue was basically in most of the documents at the beginning of this data set. In 1999 to 2010, most of the work was being done in scientific. We was trying to understand quantum and transit control, quantum control in early days. And now much more of it is in these transversal topics, developing a strong industry, developing a strong workforce, and in these applications, the quantum pillars, making it applicable to society, getting use cases for quantum computing and use cases for communication and things like that. That's the overall picture. We're going to see it in quite a bit more detail in just a moment, which I'm looking forward to. And later on, we might see whether these changes are reaching the job marketplace. But let's start by understanding sort of the overall picture. So a sort of small question for you all before we move to the first interactive activity is, what do you think about this? Does it resonate with what you would expect? Is it sort of along the lines of what you might think? Have you noticed something like this yourself? If you've been working in the field for more than 10 years or 5 to 10 years, you might notice these changes yourself. Any comments or thoughts? Oh, go ahead, Ruben. I don't think we can hear you quite properly. Do you want to maybe type it into the chat, Ruben? Because I think we can't quite hear you. Okay, great. Yeah, just type it into the chat. And we're going to go now to an interactive activity anyway, so we're going to have time to sort of discuss it in a bit more detail. That's really what I'm hoping we're going to get out of this. Great. Okay, so the first activities, we've got 3 in total today. We're going to do the first 2 now. We have created a chatbot, essentially, where we've uploaded all of the quantum national strategies and we've programmed it to be able to compare between 2 strategy documents and to give us answers about what the different countries are doing. It's one thing for me to tell you what's in the documents, but it's another thing altogether for you to go and actually have a look at them yourself and play around with them. And so that's what I think we should do today. So I'm going to put the link into the Zoom chat. Great. And you can go ahead and just follow that link, and you should pretty quickly get to the strategy chatbot and just click through the tutorial and you'll see how to use it. It's quite simple. So it's quite simple. Just click through the link there, and you're going to get to the tutorial. You select a number of documents by using the drop down on the left hand side, and then you just type questions into it. If you've ever used anything kind of ChatGPT or anything like that, then this is going to be something familiar or something you've seen before. To start with, I think you should select just one document. Select a single document in the side panel and make sure that you press restart the chat at the top after you've selected the document. So you've got a new chat with the one document selected. And then we're going to go ahead with activity 1. We're going to start off by asking, what are the core pillars of this strategy document? Does the strategy for the nation account for workforce availability? What's the plan for governance? And you choose the document, and you don't have to use these exact questions. You can ask any questions you like, but try asking these ones, for example, but you can choose other ones if you want. And try to make sure you refer to the specific country or the specific document in the prompt. Otherwise, you might not get a coherent answer. You might, because this is an AI, it knows about all of the documents in the world. You need to be specific in what you ask for. So you need to ask about this document, the one that you select. Great. So, okay, I'm going to go ahead and select one myself. I'm selecting the South Africa one. And let's see what happens. So let's take a few minutes on this, and then we're going to come back and discuss it together.
Simon, hello, Simon.
Hi, Henry.
I think there's a question on the chat.
Ruben, question is this. It seems the quantum study is still at the educational level. Are you now pushing it to the industry? Yes, absolutely. So the work that we've personally been involved in the EQRC in the past few years has been pushing in the educational domain to try to improve the workforce. But we believe it's very important to understand what we're working towards. And so that's why we're doing this research and we're doing this work on the ecosystem. And so this is an example of what we're doing in the ecosystem, where we're looking at the strategy documents and we're trying to understand the strategies worldwide. But you're going to see also a little bit more later of some of the work we've done with the companies, also in understanding their challenges and what they have to do in order to be successful in quantum. So yeah, we're pushing it to the industry because we believe that there has to be that coordination between the workforce and the industry. The one won't exist without the other. And so really they're two sides of the same coin. Great. Has anybody made any progress with the activity number one? Has anybody got any results from the chatbot? I'd love to hear. But anybody who's had any kind of result, maybe put it in the chat or we can talk about it because I think this is the most sort of valuable part of the today's session is that we can actually talk to these documents and we can actually understand very much in detail about what their content is. Okay, I put actually Google Doc in the chat, and so anybody who's done with activity one, just copy and paste or summarize your answers in the document. Anybody who's finished it, once we get a few answers in, I think we can move to a second one. But let's try to see what we can find in this first task. Ooh. Yeah, okay, so that's interesting. I already see, Peter, you found research and development, workforce development, infrastructure, industry partnerships, and international collaboration. And then somebody anonymous in the document has found their pillars are computing, simulation, communication, and sensing. So that's interesting, and that's a different focus in the document, right? Some documents are focusing a lot more on the technical R&D of the particular subjects. Yeah, there we go. Like that's justice, that's your ones. And whereas some documents are focusing much more on these transversal aspects, on trying to give, sort of develop, put, for example, things like the Quantum Initiative Act, things like equitable access to hardware, or things which are more transversal, which can be used by all of the technologies or the application domains. Yeah, so there are different approaches to doing it, and you can see, and you can ask them in more detail. For example, Justice and PT, you can ask them, you know, uh, talk about with them with respect to one of those pillars. So, say with respect to computing, what are the research and development plans for computing? You could ask that, for example, and then you'll see also that they're definitely different in the different nations. Great. Okay. Anybody else got an answer to one of those? What's the plan for governance in this document, for example? The third one. Yeah, this Google Doc, it was a bit of an experiment. I'm glad to see we're filling up with text in there. That's great. Yeah, you can just pile a text into the Google Doc. Yeah. Justice, comprehensive stakeholder engagement. So that's the third question. This is the plan for governance, I guess. And which document is this? Okay, yeah, the EU. Great. So we're going to see actually shortly that the EU is a very big focus on, I already mentioned the community building in the education world, but also in the more strategic research and technology development. The EU has a very strong focus on bringing in a big community, particularly with all of the different member states, it's sort of necessary, I would say. Great. Okay, I think we can go briefly to activity 2. So if you press on restart chat there in the chat box, so as many people as possible can do this. Select 2 documents and then press restart chat. And now we're going to be able to compare 2 different documents or 2 different nations. So I'm going to do this as well. Okay. Okay, so let's select 2 documents and compare the focus on one of the application domains, for example. Or you could pick another domain like workforce, or you could pick a domain like industry development or innovation. Great, Charles. Okay, that's an interesting one. Documents treats all 4 areas as fundamental, but the 24 strategy provides more integration with digital infrastructure. Yeah, so that's a more recent part of the EU strategy. So this is from the EU documents, as opposed to maybe the older ones where they talk more about the application domains without thinking as much about integration with the other digital technologies. This idea of integration with the digital technologies definitely becoming more prevalent in the documents as well. Something that we can consider. Okay, we're getting quite a few here. Yeah, the US one. What did we compare here? The US and the Chinese one. I would say the US and China, in many ways, are quite similar in their strategies. And we're going to see that a little bit later when we look at the strategic narratives. And that's a big part of it. A big part of the difference between them is in how they talk about what they want to do as well. So I looked at Russia and India, and in the Russia and in India, we found, let's see, I'll put it in the chat here. They're talking about using quantum computing for combating cybercrime, and for eliminating threats on security. So they have quite a strong security and national security kind of focus in the Russian document, which also maybe not so surprising. Whereas the Indian document, they're talking more about quantum chemistry, drug discovery, material behavior, logistics, more pharmaceutical development, financial communications, weather modeling. So the Indian document is very strong on the societal applications of quantum, where the Russian one is a little bit more on the sort of defense aspects. So those are sort of interesting differences as well. Okay, I think we've had a good amount of time on this activity. Maybe now is a chance to quickly round up on what are our thoughts from doing this. What do you think about the documents, having now been talking to them and looking at it? Of course, you can keep this link and you can use it whenever you like, and you can share it with your friends, and you can, if you want to be able to read these documents, you now know what they all are. You can find them all, so you can do that yourself. And then there'll be a scientific paper with more detail about the research as well. But do we have any final sort of roundabout thoughts about what we've learned from this, what we've learned from different documents? They're quite diverse in the kind of details of what they say, but some of the main topics are recurring ones. They talk a lot about industry and innovation, and they talk a lot about obviously the four pillars. You'll be hard pressed to find any document which doesn't mention computing and simulation, sensing and communication. They're all going to mention it in different aspects, but some of them are going to really focus on it, and some of them are thinking more about future perspectives. We're going to see very, very shortly a little bit that the way that they talk about it is quite different. Yeah, great. I'm glad that the people you seem to be enjoying it as well. I hope that it's also fun and interesting to do it this way. I think it's more interesting than me just talking at you about going through each document one by one or giving all of the common themes. I think it's interesting to discover them for ourselves. Okay, then I think we can move on from this activity. As I said, please feel free to keep playing away with it in the background if you want. But we're going to have a final activity soon, which is going to be also a sort of chatbot type activity. So you may want to wait till we get to that. Okay, great. Strategic narratives then. So this is our next topic for today. How do the nations prioritize, and what do they even do, and where do they even start when they're planning to write a national strategy? Um, so in Europe, as I mentioned before, the governance of the quantum flagship and the EU funding is quite community based, and they have a lot of different advisory boards and so many boards for kind of getting information from the community and making sure the community get on board with anything that they do in terms of funding. And so that's something that's been quite important in Europe. And so that's one way that sort of talk about quantum is it's for the community. Um, and what made me actually think about this from the research, what made me think about looking into this topic of the strategic narratives, was this game created by ICFO, the Institute of Photonic Sciences in Spain. And the ICFO, they're really great people because have a very strong focus on outreach and communicating quantum to the public. And they created this card game called the Decide game for the Quantum Decide game. There's a QR code if you want to download it there. Um, you have to print it out, but it's basically a card game where you get these information cards about quantum. You get the cards about what the technology does, how it's developed, what it does for society, and you get information about the people making it, and they tell you little anecdotes about what they're doing. So, for example, there's Dr. Isidora there. She's a biochemist, and she thinks that quantum computers could significantly improve our simulation programs, and it could reduce the need to experiment on living beings. You get lots of these cards with information about what quantum is going to do for us. And then at the end of the game, you have a debating, and it takes quite a long time because it's a group activity done. I've used it with students before, but you can use it. Policymakers have also used it. And getting any kind of stakeholders in a room and playing this game is very fun and interesting. And they have a debate. They see all of these anecdotes, and then they have a debate about what we should do as a government. Should we invest as much as we can in quantum? Should we maintain a current investment in quantum as it is? Should we prioritize other things because there's only so much money to go around, and quantum maybe is too far away, or it's too the applications are not direct enough? Or should we prioritize basic science so that we understand quantum better because there's still aspects of it we don't even understand as a scientific community? Um, so this was sort of this is the premise of this game, the Decide game. I really recommend using it. But the reason I brought it up here is because this is actually what made me think of looking into these strategic narratives. Because I realized from playing this game and using it as a way to create debate among people who are learning about quantum, just how difficult it is to actually come up with a clear narrative and strategy for a country. And so I thought that we need to understand on how they choose what to invest in and what not to invest in, and when. The when is a crucial part as well. So please download the Decide game if you want. It's a really nice activity. And it's an excellent analog for the decisions policymakers have to make regarding quantum technologies. And it's not a monolithic decision. You can choose to prioritize particular technologies. For example, Taiwan has relatively deprioritized communication compared to some of the other technologies. You can see it here in the Thai quantum strategy. They have a big focus on simulation and a much smaller focus on cryptography and communication. Not to say it's not there at all, but they don't think that they're going to be a world leader in it, and they're not trying to be either. And it wouldn't be a good idea for them to try to be. So how do you know whether you should try to be a world leader in something or not? Or how do we talk about that? In fact, a sort of way to think about this is whether or not you're first in line, you're sort of a first mover, or you're a second mover in line, a strategic second mover, you might say. Are you going to be the world's first sort of leader in this topic, or are you going to be quickly leveraging somebody else becoming the first sort of leader into your own success? And so this is very relevant for companies. Companies have to think about this all the time, and we've done some interviews with companies and where we've looked at this. And nations, governments have to think about this with respect to their countries as well, because the dynamics are not that different between countries in the global ecosystem and companies in the market. Yeah, great. So just from some examples of what it means to be a first and second mover. In the AI world, the US was the first mover in foundational AI research, in venture capital, in early funding. And so the US has been dominant there, but the EU has been positioning itself as a second mover. We didn't do much of the foundational AI research, but we've had the bigger AI Act. With the governance, the trust, and the recognition is much higher in the EU, and we're using the AI as much as they are in the US, and so we didn't have to develop it. We're still getting a big benefit out of it. Semiconductors is perhaps an even stronger example. Taiwan is dominating in the semiconductor world because they have this TSMC, this company where people where sort of 80% of all the AI chips are made in this one factory in Taiwan. So they have a huge strategic advantage in semiconductors, but they were not the first mover in the field at all. The US was actually again, but the US is not where most of the chip manufacturing is now. And so TSMC developed a particular niche as a second mover in the field of semiconductors, and then they captured a critical choke point. So at a point where the US wasn't innovating as much, the Taiwanese did, and then they've sort of captured a huge swathe of the market there in Taiwan. And so we can apply the same exact thing to quantum. Oopsie, we've gone past. We can apply the same exact thing to quantum, that early research and commercialization, being the first to do that doesn't necessarily mean that you will have the longest term best outcome. Taiwan, this is the TSMC, the semiconductors as an example. They've just had a steady increase in they were not the first to create high impact chips. The US were way ahead of them, but they've taken off since the rise of AI in 2020-ish. You can see the big increase since then. And so they've sort of benefited from the ecosystem at that time. The first movers do not always win out in the long run, and so in the quantum strategies, whether or not nations want to be world leader in quantum computing right now, or in 5 years, or in 10 years, or in 20 years, um, or do they just want to use it and use it for the societal applications, is a choice that you have to make as a strategy, and that's something that you should consider when you're thinking about the strategy in any new strategy that's being made. Exactly. So what's characteristic of a first mover nation or a first mover region? Establishing very strong infrastructure, critical infrastructure like innovation hubs and technological parks that can attract companies and where venture capital can be allocated is important. Another first movers often put in huge amounts of money, way more than other nations because they needed it at that time. So strategic resource allocation. Um, Regulatory framework, so setting early global standards. If you want to be the world leader in something, you have to be the person or you have to be part of the movement that's setting up the thing, the standards for the thing that you're creating. And so that's what the regulatory frameworks and the standardization. That's very important for first movers as well. And having a talented workforce and attracting talent as well. It doesn't necessarily have to be that all of the education and training is in your nation, but it has to be that you get access to the top graduates. So maybe it's because you train them yourself, or maybe it's because you have a very attractive scheme to bring in talent from abroad. But that's something that you have to consider when you're trying to be a first mover. But it's very important to get access to those things. Great. So those are some of the key sort of strategic outcomes of being a first mover nation, the things that you have to consider. Quantum computing, you could replace it with any other technology and it would also still be true. You have different aspects that are needed to be a first mover. What do second movers do then? By contrast, second movers are more about adopting of best practices, learning from the successes and failures of other nations. So they avoid the pitfalls that other nations maybe spend a lot of money developing something that ends up being a dead end. Second movers have the benefit of hindsight. They don't have to do that. So that's a great benefit for them. They will probably leverage strategic partnerships, maybe international partnerships, for example, and they can use that to leverage existing knowledge and technologies that are developed in other countries to accelerate their development without the initial heavy investment associated with building that technology. Second movers can focus their resources on specific areas that first movers have already established are either the areas that the first movers didn't go for or that they found that they couldn't go for whatever reason. Second movers have now got a landscape in which to navigate where the first movers have already established what the landscape looks like. And finally, they may be better at creating more business-friendly environments because they're able to again move in this evolving landscape. So they're able to know a more stable situation, which businesses will tend to like and investors tend to like. Maybe it's like imagining if you're an investor, it's like maybe a smaller potential gain, but a larger, but a safer bet. Whereas a first mover might be a huge potential gain, but potentially a less safe bet. So as an investor, that's something to consider. And countries, we are also, nations are investors. Great. So we see both of these narratives in the documents, the first movers and the second movers, and different nations have a different focus on each one. And actually, that's what we're working on at the moment in terms of our research. We're now working on quantifying this in terms of, scoring the different documents and the different nations on how strongly they are first movers or second mover nations. But I think that this is a really important concept. I think this is a concept that's not talked about very much. And that, we don't necessarily need to be the best at everything at the beginning. We want to collaborate with other nations or attract investment from other nations. So we don't necessarily need to be the first mover and the best at everything straight away. That's, I think, very important. So some examples of some elements of how it actually looks like in the document. This is from the Danish National Strategy. first move, Denmark's one has got quite a mix of first mover and second mover elements. So I wouldn't say it's very much a first mover. Like the US tries often to be very much the first mover, and China also. Denmark is somewhere more in between. So, for example, technology leadership institutes and developing centers and full stack components to be developed in Denmark. That's a big first mover sort of initiative. Supporting Danish firms in producing the components for the whole stack. That's another Danish initiative. Specialized Quantum Certification Institute is something that's in the Danish quantum strategy. So they want to be Europe's certifier of quantum devices, software, randomness, and they want to monetize the testing and be the certification body for Europe. That's a very first moverish kind of strategy. On the other hand, there are some second mover elements in the Danish strategy as well. So they want to be a place to incentivize global firms to invest and locate themselves in Denmark. Global firms will be already doing a certain kind of technology development, and they move to Denmark in order to commercialize it more. That's very much a second mover kind of strategy. They want to have Danish adoption in Danish quantum adoption consortia. So building alliances with different sectors like the energy, the shipping and pharmaceutical sectors to develop and deploy quantum tools. So Maersk, which is the Danish shipping company, Denmark's biggest company, you may have seen it before. They want to start using quantum optimization for global routing. The quantum optimization, Denmark's not creating this as a concept, and certainly not a conceptually first mover in that, but they want to use it in the Danish ecosystem. So those are just some examples. Denmark aims to adopt technology and adapt and adopt technology developed elsewhere for Danish applications. So those are some examples of some second mover elements in the Danish strategy. So every strategy has both, but there are different, there are different degrees to which some nations are more towards the first movers, some nations are more towards the second movers. Great. Okay. Companies also need to consider this. Like I said, nations and companies from a sort of business sort of management perspective, but they don't have to operate that differently because we're talking about how we invest our money at the end of the day. Companies also need to consider this. And so, there are some obvious pros to being a first mover in that you are a market leader, you have brand recognition, you take advantage of the initial waves of funding, you get the first access to the workforce, you drive the innovation. But on the other hand, you have higher risks, much higher uncertainty, very fast evolution, and you can fall behind easily. Where second movers have a more mature market that they enter into, they maybe improve and innovate in a somewhat more incremental way. They may be much more cost efficient as a result because they're not starting from zero. But on the other hand, they have to differentiate themselves from, it's much easier to be a second mover in some sense. So there may be more of them, and you have to differentiate yourself. And you have to find a way to overcome what's already been created or create something new. So there are pros and cons to both ways. Great. And so it's something that we did in the EQRC, and we're also finishing off the article on this at the moment. Some collaborators, Ignacio and Helene, we worked on this. We've looked at interviewing people in companies and asking them what they think about quantum and whether or not how relevant it is for their company. And so these are big companies, most of them like Siemens and Airbus. They don't only do quantum, but they have some quantum and some other aspects to their work. And the first movers and the second movers answer different things depending on their risk tolerance, depending on their ability to tolerate issues and how important quantum is to them and their business. If it's very important to them, then it's essential to have a strong in-house team. And if they're more of a second mover, then maybe they intend to partner with another company to get a stronger quantum skill in their company. Great. So okay, those are sort of this idea of the first movers and second movers. I think it's very relevant because A, it's about how the governments talk in their documents, and B, it also applies to companies and how companies decide to operate in this sort of quantum sphere. So, and it also helps to understand a little bit about what I said about the narrative and the message of quantum that we want to put out for society, because this idea of first movers and second movers we don't necessarily have to be a first mover in everything, and so we might not want to put out that message because it may not be the best one in terms of what's actually best for our country to do. Okay. We're going to do the final sort of interactive task for the day very shortly. I've introduced a few new concepts there. So maybe before we go on to this task, and I'm going to put us in breakout rooms to do this task. Have we got any questions or comments or points of discussion we want to make about this idea of the strategic narratives? Okay, I guess we can just go ahead with this task if we haven't got any discussions, but maybe we'll have some more after the task. Um, I want to emphasize that I think that quantum is not unique in being a high technology that is being developed. It's getting a lot of investment, and that we can understand a little bit about how we can develop it best by learning from other technologies that have come before. Quantum is unique certainly in some ways. In terms of the underlying science, it's very unique. But in terms of how we commercialize it and what we do now to make sure that we're successful, um, we can learn from what's come before. So that's actually something I'd like us to do in breakout rooms. I hope all of you have access to some kind of AI tool of some kind, Google Gemini or something you will probably have on your computer. And I'm gonna put you in breakout rooms, maybe 3 rooms of 5 people each. And then we can try to answer some of these questions. Just choose one. I think because of the time that we have available today, I think we can just pick one technology. And we can answer the 2 questions. Where is the technology on this Gartner hype chart that we saw before? You're going to see it again in the document in this Google Doc. So have a look here in the have a look here at activity 3 in this Google Doc. And choose a technology and one of these 50 or something else if you want. And then try to find out. You can talking in groups, you can discuss it, or you can use an AI tool and talk to a chatbot. Which nations are the first movers and which have been the second movers? Some of these are technologies which are kind of have already made it into the widespread use, and they're not necessarily being actively pushed so much anymore. I mean, we're already using 5G. It is still being pushed, of course, in some parts of the world. Maybe it's not being used in Africa yet. I don't know. Um, but but some of them are more historical, and some of them are more very much so in development in development at the moment. Neuromorphic computing, for example, or all the quantum ones, of course. So that should be clear. I'll just give you a quick example because so that you have an idea of what I mean with this. Smart grids, it's one from the list. I picked one at random. Smart grids, they're an electricity system that responds to demand, detects faults, reroutes power, and integrates multiple sources. It's not a world-changing technology, but it's a big step up from sort of dumb grids that we had before, where people would have to just switch the power on and off at different cities at different or reduce the power, and there would be people there in a control room doing it all. Um, in terms of who are the first movers and second movers, the US was definitely a first mover in the smart grids. They were very strong in pioneering the technology and the smart meters, and the early vendors. But nowadays, it's basically integrated quite heavily in many of the sort of wealthier countries in the world, like the EU, and in Japan, they've had a very strong focus on it as well. And so the US, despite being an early first mover, I wouldn't necessarily say they've had a massive competitive advantage from doing that. Not really. The EU is happy to use it and make their own smart grids, and Japan has made their own utility-led smart grids after the Fukushima nuclear meltdown. So that's just an example. And the smart grids have had a kind of an it's quite simple development, where they're now somewhere on this plateau of productivity in the Gartner cycle. They're now essentially accessible to many nations around the world, and not being talked about in the news all the time. It's well out of the hype cycle, but it's an active technology that's being used. So some of these technologies are much more, we go back there, they're much more in the hype cycle, and so they're maybe the earlier in the Gartner curve, and some of them are more in the area of productivity where they're no longer being talked about, but they're being used. So pick one or two and go in the document and then give us your answers to 2 questions. And I'm going to put you in groups to do this. There's a big table with the 50 technologies in it. So you can put your answers in the big table with the 50 technologies. So I'm going to make you in groups and I'm going to come around into each group to see how we're doing. And then we're going to go from there. Let's see. Okay, I think we're starting to come back now from the breakout rooms. So, brief thoughts on how you found the exercise? Was it interesting? Very. Oh, I'm glad to hear that. So I think you can go ahead and open the Google Doc and have a look in the table, and we can have a look and see what each other wrote and what we found out. So the top here we have artificial intelligence, and that's an interesting one because there's classical machine learning, which is kind of being used widely, and I indeed used it in my research about the documents, strategy documents. And the classical machine learning has been very widely used for a long time, and it's while there is still new work being done on it, it's not making the headlines every day. So it's very much in that productivity area. Whereas the sort of AI umbrella term and the chat GPT and the large language models is probably in its past the maximum peak of hype and heading down towards this trough of where people need to find more ways to use it productively, and people are finding lots of ways to use it less productively at the moment. And the US and the UK and Germany, we have the first movers, and then China, South Korea, we have in the second mover nations. So that's interesting. Cloud computing now, we're in the productivity era with cloud computing. The US and the UK were sort of first movers there. Um, who was doing the cloud computing? Do you want to tell us about that one? Or anybody else want to tell us
Yeah.
about digital payment infrastructure or quantum computing or HPC, high performance computing or electric vehicles?
Yeah. So
Go for it.
I think we did a HPC and yeah, and Japan and EU, then South Africa and India being the second movers.
Yeah, great. And I guess that you probably, it's probably beyond the scope of what we can do today, but you could go ahead and you could find quite a lot of history about the first companies in HPC and where it originated and where the first supercomputer was made. And so we can get a lot of information about that from online.
Okay.
I'm curious to know who made the electric vehicles because that's a really interesting one. I think that we're very much in an era where they're being used.
electric vehicles.
Was that you as well, Henry?
Yes,
Yeah.
we worked on electric vehicles as well.
So that was I think the Chinese were maybe the first with lots of the bigger companies like the BYD has become the biggest. They've overtaken Tesla, right? So the Chinese and Tesla have been kind of the first movers. Yeah. Great. So, okay. So I think that this, at least this exercise has given us maybe some things to think about when it comes to quantum, how we want to move through that hype cycle and that hype chart. We don't necessarily want to do this whole huge hype, huge disillusionment kind of curve that we're having with the AI a little bit at the moment. And so we maybe want to think about how we can do things a bit differently with quantum, being realistic with what we can do, but explaining the positives and deciding whether we want to be a first mover or second mover strategically, and we don't have to be a first mover in everything. And I think that's a really important thing to mention. Great. Okay, so we're 10 minutes left. I'll just mention to you some of the uncertainties and some of the key considerations that you have to make also when you're making this decision about whether to be a first mover or second mover. And this is from our research with companies. So this was from asking companies what they think is important. And of course, technological viability is a big one, whether quantum computing, and that was the topic of the research at the time, can actually have an advantage, whether it can surpass classical computing for certain applications. And that's somewhat unclear for most of the companies we asked. The commercial viability as well, which of the application areas are we going to find a good use for quantum computing in? Security risks and what the regulatory responses will be. The companies don't know what they're going to be. Is it going to be something that the governments in NATO make some kind of regulation about how quantum computers can be used because of security concerns? And that might affect what you do with them and your business ability. So that's something that companies also have to think about. And standardization and making sure we're able to work with other companies and other nations. First movers are going to be very much involved in setting the standards, and whether or not that's something that you want to do is also a factor that you should consider when you want to know if you're going to want to be a first mover or a second mover or not. Okay, great. So that's everything on the first and second movers concept that I think is an important one for us to understand the strategic narratives that we find in these documents. We have only maybe 9 minutes, but we'll have a very quick whiz through the research about the job marketplace, so that we have this perspective and we understand exactly what we're educating towards, I told you about. And now what does the industry look like in terms of the job marketplace and the labor market? I think that's something we also could do with understanding a little bit, and it's something we've researched, and then we'll have a quick roundup and conclusions from me. Okay, great. So I mentioned this a little bit earlier, but it used to be the case that there were more jobs than there were applicants in the quantum domain. That's changing quite rapidly with the vast number of education programs being developed across the world. But at least that was the case, and it's a good thing that there are more applicants than jobs now. It's not a good thing that there are not enough applicants to fill the roles. And so we've made some progress on that. Great. So this is some work that we have done in the EQRC alongside the work on the strategy documents. We also pulled quantum jobs from online platforms over the course of several years. We cleaned out the text in them, and then we did a kind of data analysis looking at where the jobs are around the world. So 3,641 job posts from March 23 to June 24. We have over 6,000, and then we do this kind of classification pipeline, which I won't go into, but you can ask me for more details about it if you want, in order to identify aspects from the jobs. So we have this method called human in the loop categorization, where we use a GPT classification where it's trained by human labeled jobs. So we label 200 jobs. But again, we'll go through that quickly. Okay, quick findings from this job analysis. By the way, there's a figure that I haven't included here, which is an interesting one that we made that I didn't include because I forgot, to be honest. But it shows the number of jobs proportional to the amount of national funding per country, and the number one in the world, most number of quantum jobs in the market per dollar of national funding was in South Africa. So something that's good to know is that in the African continent that you are being efficient in terms of your development, and I would love to know what's going on in South Africa to make that possible. I don't know what exactly that they're doing, but if any of you want to sort of know about that or want to tell me about that, then feel free to write me or stay at the end of the meeting. I don't know. Okay, so then the overall findings of the US and the EU are by far the most ahead. We don't have any job posts from China or very few from China, so that's unrepresented in the data set. Most of the jobs are still in super big companies like the US tech giants, but in the EU we have many more smaller companies, which is nice, 11 to 50 employees. You can see them there. You can probably guess which companies specifically are the biggest hires in quantum in the world. If you have a look there at the figure at the top, you might have an idea. Which ones are they? They rhyme with MGBA or GIBM or Google. They might be the red lines at the top there. And this is a very important point that I want to raise here because this, I would say, if there's anything to take away from this job market analysis, it's this. We compared the jobs market in the EU and the US in terms of the number of jobs available and the headquarters of the company that's hosting those jobs. And we found that if you look within the region, in the US region, there were only 15 jobs from EU companies. So there are only 15 jobs where EU companies are hosting a branch in the US. Whereas if you look in the EU, there were many times more, 7.7% of all of the EU jobs are in US companies. And what does that mean? Well, that means that the EU graduates go to work for Microsoft's branch in Berlin, and Microsoft owns the IP from the work being done by those EU graduates, and that means that Microsoft and the US are directly benefiting from the EU training ecosystem. So this is something that's really important and crucial to bear in mind is that when you have subsidiary companies establishing from other nations in a smaller country, you open yourself up to supplying the other nation with talent and something to bear in mind. And you have to think a little bit carefully when it comes to having foreign companies in your region. They use the term brain drain, which is a horrible term, but there's a little bit of that going on. Yeah, exactly. 32% of the world's companies are in Europe, but only 6% of the patents. And this is why. Okay, in terms of the degree subjects, well, graduates that go into the job marketplace, many of them come from physics, and we would expect that. But I think it's nice to see and reassuring that if you look at this graph at the top left, many graduates come from other fields other than physics, like software, electronics, quantum technologies, which is now established as a specific degree domain, in much part thanks to the work that's been done in Europe in the last few years. And that many graduates, of course, most graduates coming in have a PhD, but many have a master or a bachelor. In fact, if you add together the bachelor and master columns, they're bigger than the PhD column. So actually, more than half of the workforce do not have a PhD, which is very good progress, I would say. In the future, we would hope that even fewer percentage of the workforce have a PhD because it represents more and more commercialization and jobs where we don't necessarily need to have a very long research training in order to be able to do them. In a more mature technology, like for example, in the smart electric vehicles technology that we looked at earlier, electric vehicles, which is more along that plateau of productivity, they have many more jobs in sales of vehicles, in all kinds of technical and support jobs. Probably most of them don't have PhDs, but in quantum, still, about 40% of them do. Yep, we've made a huge stride in the number of education programs to get the time frame down from a 4-year PhD to a 2-year master or even a 1-year master. But what should be the content in those programs? Well, we talked a little bit earlier about this competence framework, and what competences are not in the framework but are in the jobs is something that we wish to study in the EQRC. And so if anyone wants to sort of collaborate on that or work with us on that, feel free to write me. We're sort of getting into that at the moment by looking at the job marketplace and identifying what's missing from this framework that's in the jobs. What do we need to teach that we don't teach at the moment? Great. Okay, a final roundup from me. I was a very fast walk through the job market research, but I think you get the general idea. The biggest takeaway is that thing about the brain drain, to be a little bit careful about how we position our graduates to go into industry and where they go to work. And other indicators are largely positive, that there are more and more opportunities for graduates to go into industry without doing a PhD. And that's good news. Yeah, so I told you about some of these earlier, but please look me up for any kind of research about the quantum ecosystem or the quantum workforce, and these are my sort of research topics. Please look me up and feel free to write me. You can find my information on the screen here, and our EQRC, our Quantum Readiness Center, the website there as well. Thank you very much for your time. It's been 2 hours, 1 hour 59. I'm happy to take any final questions or discussions, and I hope you've had a nice session today. I've also enjoyed it, and we've had some nice takeaways. Okay, great. Any final questions, comments, discussion points at all? It can be related or even not related to what we talked about, if you like.
Hello.
Hi, Daniel.
Yeah, I have a very bad network, so some of the things were really clear to me. I don't know whether I can have the opportunity to get some material to go through after this time, so that I know how to contribute next time. Because I've had a very hectic internet problem.
Yes, yes. I think that we can find a way. If maybe you can email me, Daniel, as well. Why don't you can write to me if you want to know about anything in more detail. Do you get my email address on there?
Okay. Okay. All right. Thank you, sir.
Any other final questions? Otherwise, I guess we're almost going to wrap up. Okay, well, I think in that case, I hope you've enjoyed it today and you've learned something a little bit about the quantum ecosystem and about how to write a quantum strategy. I think we've all learned something. So I guess I will let you go, and please contact me if you want to know anything more about the work that we do, or we can collaborate in any way. I'm always interested to hear from you, and to hear also about what's going on in Africa is very interesting to me. So I'd also love to hear about that. So have a wonderful day, an evening,
Okay.
and
Simon.
Oh, hi,
Okay.
Henry.
So, yeah, before we leave out,
Okay,
I
great.
would like to make some invite Dr. Martin to make some announcements. Also, thank you very much for the interactive session.
Oh,
And
yeah, great. By all means.
yeah. Okay. Oh. Hello, Dr. Martin.
Hello.
Yeah. So I was wondering if you have an announcement for the participants.
Well, I think what I can say is thank you all for joining this insightful one. And I think Simon has done a great one by giving us an activities to know how to really use the AI systems to fetch out a lot of ideas from different continents and countries, so as we can be able to formulate our own strategies. And so, Simon, thank you so much for making time and sharing with us the work you have done so far and for us to adapt it. With our participants and senior members, I can say that we have another talk scheduled next week, Wednesday, same time. I think someone will be here to show us how the organizational frameworks have been done for some of the centers and some of the strategies for us to be able to emulate from it. And so watch out for next week. I think the flyer will be out next week, Wednesday, same time, for a different section, different talk. Thank you very much.
Thank you. Okay, thank you again, Simon, for the presentation. So at this juncture, I would like to close the meeting. So we'll meet next week for the next session. Thank you all for joining.
Thank you. Bye-bye.
Bye-bye.